Okay, so let's welcome to this class. Now, this video class is the last aspect of vector. In this video, I'll be answering all the questions under vector in physics 101 textbook. Okay, so let me just start with the last question first. Okay, yeah, let me just start with the last question first. Now, if you are watching this video, just take your Phys 101 textbook. That is the textbook name is Mechanics. Okay, take your Phys 101 textbook, then open to vector, which is chapter 2 in that textbook. Open to vector and go to the last page of that chapter. That is chapter 2, the last page of that chapter. Okay, yes, please just do that. Okay, because this board is so small and I cannot be writing all the whole questions here. So I will just be reading out the question, and then I'll be reading out the question, and then I'll just bring out the parameters, then answer them. Okay, so I will start with the very last question, which is two question 2.10. Okay, I'll be reading them out. I'm coming. Okay, question 2.10. Okay, now let me read it. An object moves 5 meter north is up, and then 3 meter east, and then 3 meter is this side is east. Okay, find the, so you can look for, we should look for their distance. We should look for the, we say find the distance, and find the distance travel and what, and the displacement. Finish. Okay, so that is what they say we should look for. We should look for the distance and the displacement. Okay, now after, how will you solve this question? This is very easy. Now, this, what they say you should look for, they say you should look for distance and they say you should look for displacement. Now it's very easy. Now take note that scalar quantity, to calculate for scalar quantity are calculated by simple addition. Just add them, finish. That's how you get scalar quantity. Whereas in vector quantities, I taught you guys how to add vector quantities. We have vectorial method of adding vector quantities. We have parallelogram method. We even have Pythagoras method of adding vectors. That is when they are at right angle to each other. We also have resolution of vectors, resolution of vectors. Okay, that is also a way of solving vectors. Okay, yes, vector quantity, they cannot be added directly by simple addition. I don't know if you understand. You cannot just you cannot solve them with simple arithmetics. That we see, that is with simple addition. But scalar quantity, you can solve scalar quantity with simple arithmetics, that you can easily add them, you can easily subtract them. Okay, yes, and take note that in these two quantity, this one is a scalar quantity, while this is a what, is a vector quantity. Okay, they say we should look for the distance travel. Remember, I told you guys that scalar quantity are calculated by using arithmetic, that is by adding. Just add the two. 5 plus 3 will give you what? Will give you 8. So this is the distance travel. Remember, distance is a scalar quantity. Okay, and scalar quantity, they are calculated by using simple arithmetic. So the distance traveled is 8. Now what about the displacement? Now vector quantity, I told you can either solve them using the Pythagoras theorem, using a cosine rule, which is parallelogram method, using vectorial method, and many others. Okay, now in all this method I just mentioned, which of them am I going to use? Now if you look at these two vectors, this is a vector, this is a vector. If you look at these two vectors, they are what? They are at right angle to each other. Okay, this is a right angle. They are at right angle to each other. And how can we calculate this type of vector? We use Pythagoras theory, which is equals to, we are looking for the total. We are looking for what? The total. This displacement. So we're looking for the total displacement. Okay, which is, remember in our previous class I told you guys that resultant is the total vector or net vector. When you add two or more vectors together, the total vector you have is known as a resultant. Okay, so we are looking for the resultant here. Now we using Pythagoras theory, r is equals to root a square plus b square. Okay, now the a is 5. Okay, so it will be what? 5 square plus the b is what? 3 plus 3 square. So root 5 square, 5 square is 25, then 1 3 square is 9. Okay, if you add them, we have, if I'm not mistaken, we have 34. Yeah, if I'm not mistaken, we have 34. Then the square root of 34 will give us 5.8. So the displacement is what? Distance is 8, while displacement is what? 5.8 meter. Okay, so this is for question 1. Then for question 2, this is for the last question. Okay, now let's go to, if you look at, if you go to your, check your textbook, check that part, you find that 2.8 and 2.9, they are the same. They are, it's like they are one question. Okay, so I've solved 2.10, so let me solve 2.8 and 2.9 together. All right, so 2.8, this okay, they said four forces. Please check your, check your textbook. Okay, let me just be calling out the question here. They say four forces, 8, 6, 2 and 4 act at a point 0 in the direction north, east, south and west. Find the magnitude of their resultant. Okay, so they said four forces. I'm coming. Four forces, 8, 8, 6, 2, 4. Okay, 8 is at the north. Then 6 is at east. Then 2 is at south. Then four is at um while 4 is at west. Okay, so for sorry about they just brought the light, so please, I hope you guys can still watch it. I'm sorry. Okay, so let me just continue, or let me just off the light. I'm coming. All right. Okay, now they said these are the vectors. These are the four forces. One of them acting on the north, the other acting on the east, the other acting on the south, while the other acting on the west. So they say you should look for that. They say if you calculate for their resultant, that is the total. How can we calculate this? It's very, very easy. Okay, so how are we going to do it? We first solve for the one in the y-axis, then solve for the one in the x-axis. There is just it. Solve for the one in the y. We had the ones in the y-axis, then we had the one in the x-axis. So remember, before I continue, take note that not this up here is the positive y-axis. Okay, up is the positive y-axis, or can also be called what? Not. While down is the negative y-axis, can also be called sat. So the negative y-axis, it can also be called what? It can also be called can also be called sat. Then this one is known as the positive s-axis, can also be called east. While this side is known as the negative s-axis, can also be called west. So how are we going to uh, how are we going to solve this question? Okay, it's easy. We add these two together. We add these two together. That is just it. When we add these two together, so you should look for the resultant. Let's just add it and see. Okay, so remember, up is positive, down is negative. Let's first solve for the total force in the y-axis. This is the y-axis. Okay, this is the y-axis. Okay, so remember, naught is what? Is plus. So it will be what? Plus 8. Or we can simply put 8. 8. Then plus. Now, the down is what? Is minus. And remember, I told you guys that south or the y, negative y, you even hear me say negative y-axis. So the south or this down is negative. Okay. So I'll do 8 plus bracket open minus 2 bracket close, because the negative y-axis is, I'm even saying it again, this 2 is negative. Okay, because it is in the south, it is in the south direction. Okay, and south is negative. Okay, now let's go to the s. Now x, we need to add these two together. Okay, now this side is at the positive s axis, so it will be plus 6 or simply 6. Remember, I told you guys that we add these two together, we'll add them together. Okay, so now be 6 plus, now this 4, it is at the negative x axis, so now be minus 4 bracket close. 8 plus minus 2 is something as 8 minus 2. 8 minus 2 is what? Is 6. Then equals to 6. While this one, 6 minus 4 is what? Is 2. Okay, so our y is 6, our x is what? Our x is 2. Now since we have gotten our y and our x, so with, if you look at it, if you subtract 2 away from this, you'll be left with what? You'll be left with 6. Okay, if you remove this line from this place, you'll be left with what? 6. Okay, if you remove 4 from this one, you'll be left with what? You'll be left with 2. Left with 2. Okay, so we arrive at what? At a right angle, and then say you look for what? The resultant, which is the total. We are going to use Pythagoras theory. R equals to a square plus b square. Okay, a is 6, 6 square plus b is 2, 2 square, 6 square is 36, 2 square is 4. So adding them, we have 40. Then the square root of 40 is the square root of 40 is 6.32. Okay, so that is the answer to question 2.8. Then we have question 2.9, which is a continuation of question 2.8. They say, referring to question 2.8, find the direction of what? Of the resultant force. We have calculated for the resultant to be we have calculated for the resultant to be um 6.32 Newton. Now they say you should look for the direction of the resultant. Okay. Now remember, this is what we get. That the resultant was going in this direction. That is northeast. So they say you should look for the direction, that is the angle. Okay, we know that it's going at the northeast, but at what angle? Okay, so that is very easy. To calculate, we use tan theta is equals to a over b. Okay, now to make this theta stand alone, we take the inverse of the tan. So the inverse of the tan, a is what? Before referring to the former question, a was 6, b was 2. So a is 6, then b is 2. 6 going to 2 is what? Is 3. Now the inverse of tan then 3 will give us what? Okay, so let me do it. Coming. Okay, so the angle will be what? Will be 71.56, okay, degree north east, north of east. Okay, northeast. Okay, yes, northeast. So 71.56 degree northeast. Okay, so the angle here is what? 71.56 degree. Okay, now let's move to question 2.7.